Good morning and once again welcome to my YouTube channel, Math with Ease by Mr. Kamotho. And in this video I want us to explain activity 3, and we're still attempting to unpack the surds. And we have already understood that surds are numbers that cannot be expressed as fractions. And even when they are written as decimals, they do not terminate and they do not recur. Examples are root 2, root 3, root 5, moving forward. By now, I know you have an idea of what we are talking about. And in this activity, we are going to be a bit practical in evaluating what could be possible in real life situations. And we are told that the diagram shows an isosceles triangle, a right-angled triangle for that matter. The two shorter sides are 1 centimeter in length. What is the exact value of x, that is the size of the hypotenuse? And we all know that anytime we are having right-angled triangle, we are allowed to use two things. One, we can use trigonometric ratios. Trigonometric ratios, these are the sine, cosine, and tangent. That is number one. We can also use what we call Pythagoras or Pythagorean theorem. Pythagoras theorem, we can use Pythagoras theorem. In this case, we are going to use number 2, which is Pythagoras theorem, such that 1 squared plus 1 squared is equals to x squared. And of course, 1 squared is 1, 1 plus 1 is 2, and therefore we can easily say x squared is equals to 2. And the value of x is going to be found when we get the square root of both sides. Therefore, x is the square root of 2. And the square root of 2 is surds. So in this case, we are having x as the square root of 2. That is how we can answer part A of that question. What is the size of the angle marked alpha? The size of the angle marked alpha. Of course, this is an isosceles triangle. You can see alpha is here, or A. This is an isosceles triangle whereby the two sides are equal and this angle is 90. It means the two base angles, this one and this one, are equal now that we are dealing with isosceles triangle. And now that this angle is 90 degrees, and from the angle sum of 180, we already have our 90. So the balance is 90. And now that the two sides, the two angles are equal, you divide by 2, then we get each angle here is 45. This angle is 45 degrees. That is the solution to that question. Use your answers to part 1 and 2 to fill in the table below. The sine of 45, now we are going to consult the trigonometric ratio. And within the trigonometric ratios, we know how it goes. We have the acronym, the SOHCAHTOA. We know what SOHCAHTOA means. Sine is opposite over hypotenuse. The cosine of an angle is adjacent of hypotenuse. And the tangent of any given angle is opposite over adjacent. We know that. So the sine of 45, which is here, as we can consult here, is simply opposite over hypotenuse. And the opposite is this side. The opposite of 45 is 1, and the hypotenuse is 2. So we have 1 over the root of 2. That is the sine of 45 degrees. The cosine of 45 is adjacent over hypotenuse. You can see the adjacent is just the adjacent side is one of the shorter side just next or beside the angle given, which is here, 1, over the hypotenuse, which is root 2. So the cosine of 45 is again 1 over the root of 2. There we are. The tangent of 45, as we can see, is opposite over adjacent, which is opposite is 1, adjacent is 1. 1 over 1 is simply 1 over 1 is simply 1. And we are done with that part of the question. Let's now go to part B. The diagram shows half an equilateral triangle ABC with sides of length 2 centimeters. D is the midpoint of AC, half of an equilateral triangle ABC. ABC is the equilateral triangle, and we know the properties of equilateral triangle. All sides are equal and all angles are equal. So before we go even far, this is 60 degrees, this is 60 degrees, and the whole of this is 60 degrees. And now that it has been bisected, then we have 30 degrees there, and the other part is also 30 degrees. This is 2. D is half of AC, which is supposed to be 2. So this part is 1, and BC is 2. It is an equilateral triangle. Fine. Find the exact value of length BD. By the use of Pythagoras theorem again, because we have 90 degrees there, we have, if we say BD, this side is 1 squared plus BD squared is equals to 2 squared. This squared plus this squared is the hypotenuse squared. And as we can see, the square of 1 is just 1. So 1 plus BD squared is 4. And therefore BD squared is 4 minus 1. 4 minus 1, which is a 3. And BD, having obtained the square root of both sides, is simply the root of 3. So BD is the root of 3. That is BD is equals to the root of 3, the length of BD. What are the sizes of the angles BAD and BAD? Already we have established that, which is 60 degrees. It is a base angle of an equilateral triangle, which is 60 degrees. And ABD is already 30 because it's obtained after bisecting one of the original angles of an equilateral triangle, which is supposed to be 60 degrees, divided by 2. Angle ABD is now 30 degrees, as we can see it over there. So we can have BAD is 60 degrees. ABD, these are angles, is equals to 30 degrees. Use your answers to part 1 and 2 to fill in the table below, expressing each answer as a surd in its simplest form. What is the sine of 30 degrees? We have to find out or to establish what is the position of 30 degrees. It is here. So the sine is opposite of a hypotenuse. Opposite is 1, hypotenuse is 2. So the sine of 30 is simply 1 over 2, which is a half. The cosine of 30 here is 30. Adjacent side within the right angle is root 3 of the hypotenuse is root 3 over 2. That is the cosine of 30. The tangent of 30 is opposite over adjacent. The opposite over adjacent, the opposite is 1. Adjacent is root 3. So 1 over the root of 3. That is the tangent. What about 60? The sine of 60 degrees. Here is our 60. Opposite over hypotenuse. Opposite is root 3 and hypotenuse is 2. So the root of 3 over 2. What about the cosine of 60? Adjacent over hypotenuse. 1 over 2. What about the tangent of 60? Opposite over adjacent, which is root 3 over 1, which is basically root 3, over 1, which is easily root 3. And that is how we can answer that question. Now, we are told down here to simplify expression like 2 plus 3 root 2, 2 plus 3 root 2 squared, expand the bracket using FOIL, and then simplify. And I wish to just do that. We have 2 plus 3 root 2 multiplied by 2 plus 3 root 2. FOIL, using FOIL, of course, you know, FOIL means, using FOIL means first 2 times 2, we have 4. Outer 2 times 3 root 2 is 6 root 2 plus 6 root 2. The inner 3 root 2 times 2 is another 6 root 2, because 3 times 2 is 6, and then there's a root 2 here. And then the last 3 root 2 times 3 root 2. This is 9 times 2 plus 18. Collect the like terms. Whole numbers, rational numbers. 4 plus 18 is 22, plus 6 root 2 plus 6 root 2 is 12 root 2. And that is how we can expand the whole of that. Thank you. Remember to subscribe, follow and share, and let us meet in the next video.